Hello and welcome to this video about similar shapes. Now I'm assuming that you've already learned about how the areas and the volumes and the lengths of the sides of similar shapes compare. You've already learned that in school, I'm sure. So this video is just to help you do the online exercise called Similar Shapes. So here are two similar rectangles and we're asked to calculate the length marked A. So if they are similar, it means this one has sort of been enlarged with everything in the same proportions as the original shape. So if this base here of the smaller rectangle is 9 and this one is 18, you can see that that is exactly twice that. So the scale factor is 2. And that means that the side A is 2 times as long as 4. So we can say that A is 2 times 4, or A is equal to 8, and it's in centimeters. So the answer to the first question is 8 centimeters. Here are two similar trapeziums, or trapezia, as the plural of trapezium is sometimes said. We have to calculate the length marked B. Well, we can see that the corresponding sides here, this 15 millimeters, that is exactly 3 times as big, because 3 times 15 is 45. So we can see that B must be 3 times as big as that corresponding side, which is 20 millimeters long. So B is 3, that's the scale factor, times 20, which is equal to 60, and it will be in millimeters. Here are two similar shapes. Calculate the length marked C. So we're going to assume that these are corresponding sides, and we can see that that is 5 times bigger than that side there. If you're in doubt, 50 divided by 10 will give you the answer 5, and that's one way you can work out what the scale factor is. So this one must be 5 times as big as C. So this time, instead of multiplying by the scale factor 5, we're going to divide that number by the scale factor to get back to C. So C is equal to 40 divided by the scale factor, which is 5. So 40 divided by 5 is 8. And the units are millimeters. So that's our answer. C is 8 millimeters. Here are two similar parallelograms, and we can see corresponding sides here. The longer side, that's 1.75 and that's 3.5, both in meters. So the scale factor we can get by dividing the 3.5, the longer side, by the shorter side, which is equal to 2. So the scale factor is equal to 2. Now we have to find out D. Well, D corresponds to this side here. But because it's a parallelogram, opposite sides are equal. So that would be 52 centimeters. So this time we've got the larger side, so we have to divide by the scale factor. So D is equal to 52 centimeters divided by that scale factor of 2. So D is equal to 26, and here the units are centimeters, and that is the answer. Let's say we have a rectangle 3 centimeters by 5 centimeters, and we enlarge it so that it's a similar shape, still in the same proportions, but this time the width is twice as long, 6 centimeters, and the length is twice as long, 10 centimeters. So the scale factor is 2. What about the areas of these shapes? Well, the area of the smaller shape, 3 times 5 is 15 square centimeters. And the area of the larger shape is 6 times 10, 60 square centimeters. So, if we have a scale factor of 2, the area factor is 4 because 60 is 4 times as much as 15. We've had to multiply 15 by 4 to get the area of the new shape, not 2. That's interesting. So what if we have that 3 times enlargement, a scale factor of 3, such that the width is 9 centimeters, the length is 15 centimeters. Now we've got a much larger area. So if the scale factor is 3, how many times bigger is 135 than 15? Well, if you divide 135 by 15, you'll get the answer 9. So the area factor is 9. When the scale factor is 3, the area factor is 9. So the result so far, if the scale factor is 2, the area factor is 4. The scale factor is 3, the area factor is 9. And if we did have room to do the scale factor of 4, we'd see that the area factor is 16. Now, can you see a connection between these numbers? 2 and 4, 3 and 9, 4 and 16. Yes, the area factor is always the square of the scale factor. 4 is 2 squared, 9 is 3 squared, 16 is 4 squared. So the area factor is the square of the scale factor. So here's the examples for questions you might find in level 2. Right, here we have 2 similar hexagons. The area of the small hexagon is 32 square centimeters. Work out the area of the larger hexagon. Well, I can see that these corresponding sides here shows that we have a scale factor of 2 because we've multiplied the 5 by 2 to get the 10 centimeters. So the area factor is going to be 2 squared, which is 4. So the area of this is going to be 4 times 32, which is 128 centimeters squared. Here we have 2 similar shapes, and in this case the area of the larger shape is 68 centimeters squared. We need to work out the area of the smaller shape. So what is the scale factor? Well, if we divide 3.4 by 1.7, we get 2. So this scale factor is 2. So that means the area factor is 2 squared, which is 4. But in this case, we want the smaller one. So instead of multiplying by 4, we're working backwards. We're going to divide by 4. 68 divided by 4 is 17. And that's the answer. The area of the smaller triangle is 102 meters squared. The area of the larger triangle is 918 meters squared. The triangles are similar. Work out the length marked x. Well, I need to know the scale factor then. But with the information I've been given, I can work out that the area factor is 9. So that means the scale factor must be the square root of 9, which of course is 3. So x must be 3 times 20. X is 60 meters. Now what you've learnt about area factors equally applies to surface area. So the surface area of the largest cylinder, so that will be the curved surface area, and I guess these two circles at the top and the bottom, altogether that's 3,200 square millimeters. And the smaller one is 200 square millimeters. And they're both similar shapes, so they're in the same proportions, and we've got to work out the height of the largest cylinder. So the area factor, we had to multiply 200 by 16 to get that, and you can work that out by doing that division. So we can see that the area is 16 times as big, so the scale factor to get this height here is going to be the square root of 16, which is 4. So we need to multiply 37 by 4, which is equal to 148, and the units will be millimeters, but we're asked to give the answer in centimeters, so it'll be 14.8 centimeters, and that's the answer to this question here. Okay, have a go at the questions in the online exercise. Don't forget to keep pressing the check button to see if you're getting them right, and earn yourself a trophy. Now let's go into 3 dimensions. Imagine that this is a perfect cube. I know it's not quite perfect, but let's imagine it's a perfect cube, and I want to make a copy of it that is twice as big, scale factor of 2. The enlarged cube would look like this, and every dimension would be twice as big. So this width here is twice as big as this width, the height is twice as big, and the depth twice as big. So that one has a scale factor of 2. But can you see that it's taken me 8 cubes to make this enlargement? 8. What about a scale factor of 3? Well, here's one I've made where each of the lengths is 3 times as long. So this is a scale factor of 3. And how many cubes did it take me to make this? Well, 3 times 3 times 3 is 27. It took me 27 cubes to make this copy. So when the scale factor is 2, the volume factor is 8. When the scale factor is 3, the volume factor is 27. So the volume factor is the scale factor cubed. Here's another example. We have 2 similar cuboids. The volume of the larger cuboid is 6,732 cubic centimeters. What is the volume of the smaller cuboid? Well, let's look at the scale factor first. That's 22, that's 13. What did I have to multiply 13 by to get 22? Well, I think we need to do a little division here to work out the scale factor. So the volume factor is going to be this scale factor cubed. So in order to find out this, we need to divide that by that volume factor. So the calculation I need to do is 6,732 divided by that volume factor, which I'll work out on the calculator. So let's sum things up. We've been learning about similar shapes, their scale factors, area factors, and volume factors. So if we have a scale factor of 2, the area factor would be 2 squared, or 4, and the volume factor 2 cubed, or 8. That means the volume of the larger shape is 8 times bigger than the volume of the smaller shape if the scale factor is 2. Similarly, if the scale factor is 3, the area factor is 3 squared, or 9. The volume factor is 3 cubed, or 27. And we can use this same pattern for working out the factors. And in general, if the scale factor is n, the area factor is n squared, and the volume factor is n cubed. Okay, now it's your turn to have a go at the online exercise. Don't forget to press the check button regularly as you're working through the questions to see if you're getting them right. And if you make a mistake, have another think and correct your answer and then press that check button again. Don't forget to claim your trophy when you've got to the end. And there are lots more activities on the Transom website for you to have a go at to improve your mathematics, and you can claim hundreds of trophies. So, what are you waiting for? Get going. Bye.
You can find Transom Mathematics at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.